by the load carried by the front and rear wheels, that is, by how weight is distributed. In a 40% to 60% fore and aft weight distribution, 40% of the weight is carried on the front wheels, 60% on the rear, and the center of gravity is closer to the rear than the front. A weight distribution of 60-40 has the center of gravity closer to the front than the rear. Lateral weight distribution can be expressed in the same way. The height of the center of gravity is determined by the height of the mass above the road surface. Every vehicle has static weight distribution, whether it is at rest or traveling in a straight line at a steady speed. This is changed laterally by centrifugal force when the vehicle is turning, and in a fore and aft direction during acceleration or braking. During cornering, centrifugal force puts more weight on the outside wheels. Acceleration puts more weight on the rear wheels. Deceleration or braking has the opposite effect. In a turn, centrifugal force tries to push the vehicle away from the corner. This is resisted by the cornering force of the tires. The tires have slip angles due to the cornering forces acting on them, and since the cornering forces at front and rear may not be equal, the slip angles at front and rear can be different too. With the center of gravity closer to the rear tires carry more of the weight, so they operate at a greater slip angle than the front tires. Larger side forces act on the rear tires, which causes greater tire distortion. This condition of higher slip angles at the rear causes oversteer. More weight on the front tires means they corner with greater slip angles than the rear. The vehicle is then said to understeer. With equal slip angles at front and rear, the vehicle is said to have neutral steer. Radial ply tires generate much higher cornering forces than cross ply tires, which is why the two tire types should not be used on one vehicle. Slip is also influenced by inflation pressures, so manufacturer recommendations should always be followed.
Wheels are usually made from pressed steel or cast aluminum alloy. They are lightweight yet strong enough to withstand normal operational forces. Alloy wheels are popular because of their appearance and because they are lighter than steel wheels. Aluminum is better conductor of heat, so alloy wheels can dissipate heat from brakes and tires more effectively than steel. The terms wheels and rim are often used synonymously. The rim of a wheel is the outer circular lip of metal on which the inside edge of the tire is mounted, and the purpose of the rim is to hold and seal the tire to the wheel. Alright, when they're saying wheel, they're saying the rim. They're saying tire, obviously they're saying tire as well. The rim width is the distance across the rim flanges and the bead seat. The bead seat is the edge of the rim that creates a seal between the tire bead and the wheel. The rim flange is the exterior lip that holds the tire in place. The rim diameter is the distance across the center of the rim for bead seat to bead seat. The width of the rim and the diameter are traditionally stated in inches, although some are stated in millimeters. Passenger vehicle wheel rims use a drop center design. The intersection sits lower than the sides. This design allows tire removal and fitting. The drop center rim is made out of one piece and is permanently fastened to the wheel disc. The drop center is used for mounting and demounting the tire onto the rim. When inflated, the tire is locked to the rim by tapering the bead seat toward the flange, and are more commonly by safety ridges or humps close to the flange. You guys remember the drop center is a place in the rim where it's lower so you could easily remove the tire, or it helps you remove the tire. An important feature of the rim is the location of the drop center in the rim. The drop center can be closer to the front of the wheel or rear of the wheel, depending on the desired position of the wheel relative to the axle flange stock wheels. In the deep dish wheels, the drop center is closer to the rear of the wheel. Tires should remove from this side. In this top picture right up here, here's the front of the wheel. This part right here is called the drop zone. So this is a normal dismount and mount rim. This one right here, I believe it's also, I think it's forward. This might be the front. All right. So if this is the front of the rim. This is a forward remove. When you remove the tire, this is going to be on the upright position. This is going to be facing up. All right. If this drop zone right here is all the way towards the rear, this is called a reverse mount rim. That means you need to remove the tire upside down. Drop zone. Since the drop center is crucial to removing the tire from the wheel, the side of the wheel that is closest to the drop center is the side the tire should be removed from. Manufacturers and legislators say passenger cars and light trucks must have safety type drop centers. The safety type drop center ribs have a slight ridge or hump on the inside edge of the bead ledges. This ridge helps to hold the tire beads in place when the tire goes flat. It holds the tire beads in place. I said that right. So if you guys look right here, there's a little hump right there, and just little bump right there. Also right here, there's little edges. So when the tire goes flat, the outside of the tire where the bead seat is, it'll hold it on in place versus all the tire, both sides of the tire going the inside of the drop zone. Rims can be made from two sections of pressed steel, a flange or a disc that is drilled for the wheel fasteners on the rim. The rims for the passenger vehicles are usually the steel disc type. The disc may be solid, but the major manufacturers place holes to, the disc may be solid, but major manufacturers place holes in them to reduce the disc weight to provide ventilation for cooling the brakes. The disc is either welded or riveted to the rim and bolted to the axle or axle flange. Passenger vehicles usually have steel disc type. They're solid with holes to reduce the weight and allow cooling. They're either welded, riveted to the rim, and bolted to the axle or axle flange.
Wheels must be strong enough to support the vehicle and withstand the forces caused by normal operation. At the same time, they must be as light as possible to help keep unsprung weight to a minimum. Wheels can be made from pressed steel in two sections: the flange or disc that is drilled for the wheel fasteners, and the rim. Wheels can also be made from cast aluminum alloy. Alloy wheels are popular because of their appearance and because they are lighter than similar steel wheels. Aluminum is a better conductor of heat, so alloy wheels can dissipate heat from brakes and tires more effectively than steel ones. These are often called mag or magnesium wheels, but wheels made of magnesium are rarely used on road vehicles. Most wheels have ventilation holes in the flange, so air can circulate to the brakes. Most passenger car wheels are of well or drop center design. This design allows for tire removal and fitting. Tires for heavy goods vehicles are much stiffer, but they can also be fitted to a well-based rim or to a flat-based detachable flange rim, depending on construction. To ensure correct fit between a tire and a rim, all manufacturers of wheels and tires comply with standard dimensions, as recommended by tire and rim associations. The width of the rim is the distance across the rim flanges at the bead seat. Its diameter is the distance across the center of the rim from bead seat to bead seat. The shape of well-based rims is provided by a letter code, such as J, K, JJ, and KK. The width of the rim and the diameter is traditionally stated in inches. A rim designated 7JJ by 14 would refer to a rim measuring 7 inches across the rim flanges and 14 inches in diameter from bead seat to bead seat, with the profile conforming to a JJ code. The rim width and diameter can also be stated in millimeters. Metric rims are not interchangeable with imperial rims. The tire must be an exact fit on the rim to fulfill a number of functions. It ensures that the narrow contact area between the beads of the tire and the rim will seal the air in a tubeless tire. It transfers all the forces between the tire and the wheel without slipping or chafing. It ensures the friction between the tire and the rim prevents the tire from turning on the rim.
And the wheel offset is the offset of the wheel is the distance from its hub mounting surface to the center line of the wheel. It brings the tire center line into close alignment with a larger inner wheel bearing. This reduces the load on the stub axle and requires space inside the wheel assembly for brakes. An offset can be 0. The plane of the hub mounting surface is even with the center line of the wheel. The vehicles manufactured in the mid-70s through the 80s were typically built with 0 offset wheels. A positive offset is the plane of the hub mounting surface is shifted from the center line towards the outside of the front side of the wheel. A positive offset wheels are generally found on front wheel drive vehicles and the newer rear wheel drive vehicles. A negative offset is when the hub mounting surface is towards the brake side or the back of the vehicle, the wheel center line. Older model vehicles are specialized high performance vehicles with deep dish wheels typically have wheels